Now we're going to go ahead and prove that for a triangle, the measure of angle A plus the measure of angle B plus the measure of angle C, or the sum of all of those interior angles, adds up to 180 degrees. Some might be something you already knew, but we're going to actually prove it here. Now, one of the things about a proof is you should kind of plan out like, well, we're trying to prove that these things add up to 180 degrees. Well, where have we seen that before? Well, one, we've seen it very recently with the same side interior angle theorem. So we might be dealing with some parallel lines that might be useful. And where else have we seen it before? Oh, straight angle theorem. And if you can't remember what that is, it means that if we have a line and we have it cut up into a few different angles, then we know that those angles add up to 180 degrees. So this is kind of our little planning area here. Great, so we have an idea of what to look for. We can look for some same side interior angles, or we can look for a straight angle. And now we have to figure out how to construct that. Well, there's a couple different strategies, and part of this just comes from experience, but well, what if, since we've been dealing with parallel lines, what if we create a parallel line? And it doesn't actually matter which one we use, but I'm going to create a line that's parallel to AC, but then travels through point B. So I have these two parallel lines here. Now, what that's going to allow me to do is take angles A and C here and get them up there with angle B. And you'll notice, oh, you know what? This looks a lot like my straight angle theorem, doesn't it? So remember, with parallel lines, we can only deal with one transversal and two parallel lines. Clearly, the two parallel lines are going to be the same here for both examples, because we only have one pair of parallel lines. We have these two parallel lines there. But now I need to pick my transversal. I'm going to go ahead and pick this as my transversal first. So I can clearly see here that angle A must be congruent to this up here because those are alternate interior angles. Again, only use the highlighted lines because I can only use 3 at a time. So for example, pretend this line here doesn't exist, BC. It's not something we're using. That must be the measure of angle A right there. Well, I'm going to ignore that transversal for a moment, and then I'm going to pick a different transversal. Well, I'm going to pick the only other transversal that's possible is this one right here. And that seems to work out really nice because I now can take the measure of angle C here and use that same alternate interior angle trick right here. And you know what? I'm just about done at this point because I know that this is just the measure of angle B right there. And the measure of angle A plus the measure of angle B plus the measure of angle C form a straight angle. So I've actually proved this at this point. Now, what I'm going to do really quickly here is I'm just going to kind of mark down the reasoning behind this. This is a very informal proof here, but I knew that this angle here was equal to the measure of angle A because of the alternate interior angle theorem. I knew that this angle was angle C also because of the alternate interior angle theorem. I knew that this line was parallel. Well, that was just by construction. So now that we have justified all of our reasoning there, I'm just going to put a quick note here that the final reason that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees was just that straight angle theorem. Those three angles form a straight line, and we know that a straight line contains 180 degrees.